So if we want to find the inverse of this graph, what do we do with our points? Your x's and y's become what? Flipped. So the y becomes the x becomes the y, right? That's what inverses are. Your x becomes your input becomes your output, and your output becomes your input. So 1, 2, 3, 4, 5, negative 6 and 0 is going to become 0 and negative 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, negative 4 and 1, 2, 3, 4, 5, 6 is going to become 6 and negative 4. And then I'm going to connect them right away so that I know that that was the next one that was to it. And this one's at negative 1 and 1, 2, 3, 4, 5, 6. So it's going to be at 6, 1, 2, 3, 4, 5, 6, and negative 1. And I have 1, 2, 3, 4, and then 1, 2, 3. So 4 and negative 3. So that's going to be negative 3 and 4. Oops, to the wrong dot. And the last one is at 1, 2, 3, 4, 5, 6, 7, and 0. So it's going to be 0 and 7. 1, 2, 3. Bless you. So to answer all three of those questions over there, the domain and range of the original, domain and range of the inverse, and the number of invariant points, I didn't have to draw this graph. Because, let's think about this. So the domain of the original, Everett, can you get the front light, please? Thank you. The domain of the original, we're going to do it in set notation and interval just so that you get used to both, because they can ask you either way. Our lowest x is 1, 2, 3, 4, 5, negative 6. Our highest x is 7, right? So if we do set notation, it's going to be x such that negative 6 is less than or equal to x is less than or equal to 7 xer. If we do it in interval, it's between negative 6 and 7, so I do that. And because it's equal to, you get a square bracket on the 6, and it's equal to, you get a square bracket on the 7. So for the original, I don't need to sketch the inverse yet, right? For the range, my lowest y is 1, 2, negative 3. My highest y is 1, 2, 3, 4, 5, 6. That would be between negative 3 is less than or equal to y is less than or equal to 6 yer. Why do I not need to draw the inverse graph? Does anyone have any idea why I wouldn't have to draw the inverse graph in order to get the domain and range of the inverse? When you find the inverse, what are you doing? You're finding the opposite. So your x's become your y's, and your y's become your x's, correct? Your x's become your y's, and your y's become your x's. What's domain based on? X. That's now going to be your y. So now it's going to be your range. What's your range based on? Y. It's now going to be your x, so your domain. So actually, if we have the domain and range of the original, the exact same for the domain and range of the inverse, except x's become y's and y's become x's. So if you actually only have to do interval notation, this just goes over there and this comes down to range. I didn't have to draw the inverse at all because my x's and y's switch. So my inverse, my domain is my range with x's. X such that negative 3 is less than or equal to x is less than or equal to 6 xer. Or I can just take this interval notation and write it, and I didn't even have to put in x's because interval notation doesn't have the letter. Then my range is just my domain with y's. So y such that negative 6 is less than or equal to y is less than or equal to 7 yer. Now, number of invariant points, or even what the invariant point is. Why do I not have to draw the inverse? in order to figure out how many there are? Where do the invariant points happen on an inverse graph? On the reflecting line. What's the reflecting line? Y equals X, also known as the identity line, right? So if I draw the identity line, which is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Yeah. Now, by drawing them, you see it crosses in one spot. But then some people are like, but these are invariant too. They didn't change. Actually, they did change. This used to be this point, and like that, you know, they did change. They're not the same point. This one physically did not change. Okay? Because they don't change if their points are the exact same x and the exact same y. Invariant points only exist on inverse graphs when the x and y's are the exact same. So 3, 3 turns to 3, 3. 1.3 and 1.3 turns to 1.3 and 1.3. It's the same point, right? This one here is like 1 point, I don't know, 1.5 and 1.5. It's drawn off a little bit. So the 1.5 and 1.5, still the same even if it's a decimal, right? So did I need to draw the graph in order to see that it only crossed in one spot there? Or if I actually took the inverse off completely, I can just draw my y equals identity line, y equals x, and say, hey, it crosses once. So when I draw my inverse, it's going to actually cross there. And I could give my point. I wouldn't even have to draw the inverse. Okay? You have to draw the inverse when it says draw the inverse. You have to come up with the inverse equation when it says give me the inverse equation. But if I ask you for domain and range or how many invariant points there are, I don't even have to draw the inverse. Right? Okay. We're going to skip this one and go to the next one. So this comes up a lot. This is actually in the curriculum. We have to, well, everything's in the curriculum, but this is very much in the curriculum. It comes up a lot. You have to, what they told us is, if you're given a function like a parabola, when you draw the inverse of a parabola, excuse me, you have a parabola, let's say it's like this, correct? When you draw an inverse of a parabola, which we did yesterday, what happened? It turned sideways, correct? Parabolas, quadratics, any polynomial, degree 1, degree 2, degree 3, degree 4, they're all functions. What is a function? You learned it in grade 10. And then you carry it on throughout. A function says that for every x, there's only one y. For every input, there's only one output. What does that mean? If you draw vertical lines, every x value should only cross one y value. So you should only have one crossing, correct? So on a quadratic, if I draw vertical lines, cross in one spot, correct? Now, when I do the inverse, is it a function? No, every single one, it's crossing in two spots. If at any point in time it crosses in more than one spot, it's not a function. So even if for a whole bunch of parts of the graph it crosses in only one spot, the moment it crosses in more than one spot, it's not a function. It doesn't, there's like not like a limited amount you have to hit in order for it to not be a function. The moment it crosses in more than one spot, the moment for every x there's more than one y, it's not a function. So what they want us to do is they want us to somehow figure out what I can restrict my original graph, the domain to, restrict the x values, so that when I actually do draw my inverse, it is a function. So how would that be? Well, if this graph here in particular didn't have the bottom half, it would be a function, right? If it didn't, if I kept the bottom half and it didn't have the top half, it would be a function, correct? If I took more of it even if I took it up all the way up to here, it would be a function, right? The only catch is that you can't have a little bit of a, like the vertex, right? You can't have more than just up to the vertex. So, once again, I don't even actually have to draw the inverse to figure it out. So, say I drew my original, say it was this, correct? Remember, inverses, your x's and y's flip, correct? So if I want to test if the inverse was a function or not, do I have to actually draw the inverse? No. How do I test if the inverse is a function? I draw vertical lines, correct? And if it doesn't pass a vertical line test, it doesn't pass. So if I drew horizontal lines on my original, would that not be vertical lines on my inverse? Yeah. So if I draw a horizontal line through this, does it pass it? No. So that means my inverse wouldn't be a function because that would be a vertical line on my inverse, right? So you can actually do a horizontal line test on the original to see if the inverse would be a function. Could you just draw the inverse and check? Absolutely. Go right ahead. This is a backup in just in case you're like, I have no idea how to draw that inverse, right? Or saving time, or another way to check it, right? So the catch for us is they're going to say, what do I have to restrict my domain to? So we're going to look at this example, x squared plus 1. Now from grade 11, you remember that that's actually in standard form. Well, it's in vertex form, not standard form. It used to be called standard form, and now my brain, in the old curriculum was standard form. They changed it to the new curriculum to general or vertex form. Why? I don't know. Why? Anyways, it's in vertex form. It gives you the vertex, okay? Well, how? Well, you have f of x equals, you could write this as x plus 0 squared plus 1, correct? You could write it with a 0. It's not going to change. It hasn't been translated any way to the left or any way to the right. The other way is, hey, you guys are learning transformations. Life is awesome once you've learned transformations. Your normal parabola is here. That's your basic x squared parabola, correct? Your parabola has been moved one what? One up. It's not with the x, correct? It's not with the x, so it affects the y's. So it's been moved one up. So if I just take my basic parabola, this one, I'm going to move this here. This is going to go 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 here. And this is actually the drawing of y equals x squared plus 1. I literally just take that basic parabola and I just shoved it up one. So every single thing just went up one, right? Because you guys know transformations, it's actually even a lot easier to move a parabola around and redraw it, because you can just draw your basic parabola as long as you know the basic one, 0, 0, 1, 1, negative 1, negative 1, or negative 1, 1, 2, 4, negative 2, 4. And you use your transformations, you can move it anywhere you want. You don't have to do any type of other stuff, right? So we now have this red parabola. Okay. We always restrict the domain of the original. We don't restrict the domain of the inverse. Okay, we restrict the domain of the original. And we both agreed that if I have my parabola like this, and I draw it sideways, it's like this, right? It isn't a function. However, if I drop off this side and I draw it, it's a function. If I drop off this side and I draw it as an inverse, it's a function, correct? Do you agree? So where am I cutting off the graph at? Where am I splitting it? At the vertex. So I need to know the x of my vertex, and then either say I'm going to take this part of it, the part that's greater than the x of the vertex, or the part that's less than the x of the vertex. That's how I'm going to restrict my domain. So I'm going to say, what's my vertex at? What's my x? What is this? X equals 0. Now, if I say for my domain, I'm going to restrict it to x such that x is less than or equal to 0, xer, then I would just get this part of it, right? And that part would be gone. And I'm good. Right? If I draw it, it just draws a half. Or x such that x is greater than or equal to 0. You'd have to list one or the other. You can't, both of them couldn't be there. Some people say, well, what if the diploma had both of them? It won't. Both are right. So it's not going to give you one or the other. It's going to have to give, so it's not going to give you both. It's going to give you one or the other. It's not going to be like, this isn't going to be A and this isn't going to be B. They couldn't do that. You'd have to circle A and B, right? So they give you A or B. They can also give you variances of this too. They don't have to, this is the best options. This is the options that would give you the most amount of graph redrawn. That would be a function. However, they can also give you domains that are just included in those. So I could say, I could also give the domain anything less than or equal to 0. So I could say x such that x is less than or equal to negative 2. And that would also work because negative 2 is here. And I would just have this part of the graph, right? If I draw just that part of the graph sideways, it's a function. If I draw horizontal lines through that, That means the inverse would be a function because I just only have that little piece, right? So I can also give pieces that are from here to here. But these two are the best options that will give you the most amount of graph when you redraw it. That'll be a function when you split from your domain. Okay? Let's actually draw, or let's actually come up with what the graph equation would be. So if the inverse, so we'd go x equals y squared plus 1. If I ever asked you to come up with the equation of the inverse, you switch your x's and y's. That is the equation of the inverse. That option isn't going to be one usually on the diploma that you're going to pick. They're going to make you solve for what? Y. They're going to make you solve for y. So how are we going to do that? We're going to subtract the 1. A lot of people try and square root this first. Don't do that. You have to get that 1 away first. So I'm going to have x minus 1 equals y squared. And then I'm going to take the square root. And when I take the square root, what do I have to remember, you guys? Plus or minus, the positive, negative. Because if you don't put the positive, negative, you're actually only going to get half of it, which would be good because then it would be a function, but it wouldn't be right. Okay? When we restrict our domain to this one or this one, the positive or negative sign, you'll only have one of them. You'll either have positive or negative once you restrict the domain, right? The original domain. This would actually be the equation of the inverse. Okay? This is the homework, but I made it smaller, so I'll show you what the homework is if you have that all written down. Not hugely smaller, but smaller. Nope. Nope. There. So remember, your test is on Tuesday. Your hand-in has to be in today.